Welcome, guys. This is Engineer Waqas Ahmad, and in this series of project management fundamentals, today we are going to discuss about scheduling model approaches. Very important thing. So stay till the end of today's session. All those people who are civil engineers, electrical, mechanical, management professionals, they are going to learn a lot of things because this series is going to make sure them that they are going to become a perfect project planning and scheduling expert. And why this today's video is so much important, because in today's video I'm going to discuss diverse kind of approaches for any kind of project scheduling model. So before getting into today's video details, I would request you people the same thing: subscribe this channel, share this link with your fellows, and write in the comment section area about your discipline, about your career and all that. So let's start, and I'm going to share with you this screen. Today's topic, scheduling model approaches. So next is very much pretty familiar, like there is a graph, and this graph has been divided into different kind of things. This is high frequency delivery, this is low frequency delivery, this is low degree of change and high degree of change. Let me explain about these things. When I talk about frequency of delivery, it means the deliverance of that work, right? How frequently we have to deliver that work once for all. It means low frequency of delivery, like I'm supposed to construct this bottle. So client has committed with me, once this all bottle will be ready, then I will be delivering this complete as a product. That is low frequency of delivery. But when this client is committed, no, once this cap of the bottle will be completed, I have to present this one as well. When inside there is another pipe is going through this bottle, again I have to present that one and deliver and take the feedback. Then their coloring, their different kind of core of bottles. So this is called high frequency of delivery. Now I hope you can understand about this y-axis. Now let's talk about the x-axis. Low degree of change and high degree of change. It means scope awareness. How much you know about the scope of work. Like at the start, you have no idea how your software will be developing, right? At the start, you just have an idea, right? But by the end, when it is going to be completed, with the passage of time, you are going to add up your ideas, your testing, all these things, and then you will approach that final product. But in buildings, you know very well at the start time, like how building will look like. So that there is a low degree of change. You understand? So on the basis of these different kind of combinations, if we have low degree of change and low frequency of delivery, in other words, we have to deliver all the things that is predictive life cycle, iterative life cycle, adaptive life cycle, and incremental life cycle. So let's talk about all of these things one by one. So if we have low degree of change, right, we have complete idea, like in case of road construction projects, building construction projects, pipeline construction projects, the degree of change will be low. By the end of deliverance of that product, final stage and initial stage, there is very minimal difference, right? You have complete idea at very starting point. So that is why there is a low degree of change. And low frequency of delivery, nobody knows, okay, once this road will be completed like 30%, we want to drive on it. No, once for all, once the road will be done, the factory will be completed, that refinery will be completed, that building will be completed, we are supposed to deliver. So low frequency of delivery. So this is called predictive life cycle. What are the features? Scope is clearly defined at the beginning. Detailed planning is done before execution starts. Work follows a fixed sequence. Okay. Analyze, design, build, test, and deliver. And ultimately, changes are minimal and controlled. Delivery usually happens once at the end, right? Only at the end. Like I gave you examples of road building construction projects, pipeline, MEP, combined cycles. All such kind of projects are going to follow predictive life cycles. Low frequency of delivery and low degree of change. Understand? So the best for construction, infrastructure, and EPC projects. And for such predictive life cycles, what are the scheduling models? Our critical path method is most suitable for such kind of project scheduling model, right? And in the next, we can see that iterative. Iterative, you can see over here, the combination is high degree of change, like your scope is not certain at very starting point, but frequency is once for all. So these are two combinations. So work is developed in repeated cycles because certainty is, uncertainty is too much. You have no idea how the product will be developed, what are the final features would be there, but you have to deliver once for all. So repeated cycles, continuous improvement, and then there will be each cycle improves or refines the previous work. Feedback is given, taken after every stage. The product is not fully finished in one attempt. Changes are expected and accepted, right? And then focus is on learning and improving step by step. And then suitable for software designs, applications, any AI model, they are going to use iterative models, right? So that is somehow high degree of change and low frequency of delivery is following iterative life cycle. And then there is incremental, in which the trades are high frequency of delivery. You have to deliver step by step. Every single stage you have to check by your client. But low degree of change. At very start, you know what you are supposed to deliver. So the things are the project is delivered in small usable parts, right? Each increments go through analyze, first of all, then design, then build, then test, and then deliver. Then after every increment is delivered, the next one starts. Like I will give you an example. Recently, I was making my AI model based planning tool, right? So I hired a team and I had an idea what I need, but every single stage they have given me login things. I approved that one, then increment added, then the next interface dashboard added, then their features were added, accepted, approved, then it was incrementally enhanced. So such kind of applications are going to use incremental approach life cycle. Scope is divided into manageable portions. We can't make mess it up, right? We have to see, okay, right now I'm okay for this one, this scope of work, and now the next one, which one is suitable, right? There is a sequence proper, like, okay. So that is incremental. So the next one is all about is adaptive, right? In which high degree of deliverance and high degree of changes. It is actually the combination of increment and iterative, the adaptive life cycle. Previously I have also discussed about agile. Agile is one of the adaptive life cycles, okay. So iterative plus increment approaches, work is delivered in small usable increments, continuous feedback from customers, scope can change frequently, high value features, and then suitable when uncertainties is high, and agile is adaptive approach. So I hope through this graphical representation you got a lot of understanding how scheduling model will be finalized on the basis of your product. It depends on your degree of change from the perspective of scope, how much it is clear, verified, or well defined, right? And frequency of delivery, that is going to define either you go for predictive, iterative, incremental, or adaptive or agile. So please like, subscribe this channel, and write down in the comment section area in which scheduling model you are working there. So see you in my next video of project management fundamentals.